Welcome back. This is video number 2 of this module number 6, where we are just simply going to work through some problems, give you a couple of more things to look at, and see that you really have understood the processes that we're talking about. Now, before we get started, let's take a look at what it is we have been studying here in Module 6. The first thing that's going to appear here on our screen are the objectives. Remember that we talked about writing linear equations given 3 different types of scenarios. You can see them here on the screen. Writing linear equations when you're given a table of values, writing linear equations when you're given a graph, and the one we spent the most time on, writing linear equations in 2 variables given a verbal description. Those 3 different types of scenarios were what we discussed. Now, in working those kinds of problems, we did have some vocabulary that went along with that. We talked about what linear equations were. We said every line has a name, and that name is its linear equation. And we have to be able to find those names when we work in our mathematics algebra class. We can get that information from tables, graphs, and verbal descriptions. You have a better understanding now than you probably did back then. Now, the other piece that we have been discussing today are 2 types of equations. The first equation that we studied was the point-slope form, where you have a method for writing the name of a line when you don't know the y-intercept, but you do know a point on the line and you do know the slope. Okay. The other type of equation that we studied was the slope-intercept form. This is the easiest, it's the most familiar. It's the one that you use when you know your slope and you know the y-intercept. Remember how we also talked about how the y-intercept specifically was a flat fee or a base charge or something like that that got the ball rolling on the total cost. That is the y-intercept. The slope, we've mentioned it a couple of times, is going to be the rate of change. It could be a unit rate, dollars per hour, miles per hour. Those are all unit type of rates that you might see in a verbal description type of problem. And finally, if you're given some information, but you're not given a slope at all, you're just given some data, then you've got to make use of this little formula here, the slope formula. We did some problems conceptually where we just said, okay, how did the y change? And we put that in the numerator. How did the x change? And we put that in the denominator, and that was our slope. Now, if that made you a little uncomfortable, we said just use this formula. You can choose 1 point to be the second point, 1 point to be the first point, plug the values in, and calculate your slope that way. So whether you do it conceptually or whether you do it using the formula, you do need to be able to calculate the slope. All right, let's get rid of this and let's talk about our first problem. Here's our first problem. Read it with me. Write the equation of the line given that the slope is 2/3 and that the y-intercept is -5. Now we're going to use our pause, work, resume, and compare strategy. At this time, go ahead and pause your video, work your problem out, and then hit resume, and we'll see how you did. See you in a minute. We are given the y-intercept. We are given the slope. We have all that we need to use slope-intercept form. Nothing to calculate. We're just given the material. And so we just need to remember that y is equal to mx plus b. That's our model. And so we plug the values in. Y is equal to 2/3 of x. Now we're going to write -5 here because that is our y-intercept. We didn't see that last time. If the y-intercept happens to be negative, then we sort of deviate from a plus b to a minus b because the number's negative. Hopefully that doesn't create too large of a stumbling block for you. Plus b really can kind of mean minus b if the b value happens to be negative. Okay, there's the first problem. Now let's take a look at the second one. Here is our second problem. Read through it with me. Write the equation of the line that contains the points 5, 4, and 3, 1. Go ahead and hit the pause button, and let's see how you do. See you in a minute. Welcome back. We're not told slope. We are not given a y-intercept. So what do? We have to use the point-slope form. What does that equation look like? That one should look just like this guy right here. Recall that we said we're never going to change this y and that x. We're going to leave those alone. This y and this x are going to be from the point that we choose, and then we will have to calculate the slope. Our 2 points are 5, 4, and 3, 1. How do we change to go from 4 to 1? That's our change in y. Well, from 4 down to 1, that's down 3. So we're going to call that minus 3. What about the x value? From 5 to 3, we're going down 2. So that's going to be down 2. So the change in y is negative 3. The change in x is negative 2. So our slope is negative 3 divided by negative 2. And we're going to remember that two negatives, when you divide them, are positive. And so simply 3 over 2 is going to be the slope. The fraction doesn't reduce. If it did, we would do it. It doesn't divide evenly. If we did, we would divide it out evenly and write the slope as a whole number. So 3 over 2 is our slope. If you prefer to use the formula, what was that formula? Well, remember that it's going to be this one right here. You're going to have the y value of one of the points minus the y value of the other point. So we can say 1 minus 4, and subtract the x values is going to be 3 minus 5. And so our slope in this case is going to be negative 3 over negative 2, and that's exactly the same thing that we came up with there. So there's our slope. Now how do we write the equation of the line? We're going to start with y minus the y value of one of our points. That's going to be minus 4, is equal to our slope. We figured that was 3 over 2, multiplied times x minus, now we can't change points. We got to stick with the point we started with. We started with the first point, all right, because we picked the 4 for the y value, and that means x minus 5 is going to go right there. And that's your answer. Okay? Let's work another one. Here's our next problem. Read through it with me. A handyman charges $75 an hour, but also charges $40 to come out to your home. Write the equation for the total cost for a repair job at your house. Go ahead and hit the pause button. Let's see how you do. Welcome back. Let's see how you did. I'm reading this problem. I have a $75 an hour. That is a rate. Remember that a rate is going to be your slope number. And so in this particular problem, M is going to be $75 an hour. Hopefully you figured that out. There is also a charge of $40 just to come out to your house. That is a flat fee. That is a flat rate. It's a beginning rate. It doesn't start at 0. It starts at $40. Consequently, that is our y-intercept. That's going to be the b value. Hopefully you pick that out of the problem. So we have a slope. We have a y-intercept. So which equation do we use to create this equation? Which format? Yep, that's it. Y equals mx plus b, the slope-intercept form. So we're simply going to plug these numbers in. We're going to get y is equal to m, which is 75, multiplied by x plus 40. It's plus 40 because $40 is a positive number. Okay. All there is to it. Hopefully you did well. Let's check out the next problem. Read through it with me. A light bulb company manufactures 2,000 bulbs and earns a $3 profit per bulb. When it manufactures 10,000 bulbs, it earns a $13 profit per bulb. Assuming that this is a linear function, let's write the equation. Pretty straightforward. Let's see how you do. Go ahead and hit the pause button. Let's see how you did. This problem does not give us any information directly about slope or y-intercept. There's no flat fee. There's no base level charge. There's no rate of anything going on there. So all we have is just some data. We can say that 2,000 bulbs produces $3 of profit per bulb. We also know that 10,000 bulbs yields $13 of profit per bulb. We have 2 points of data. We don't know a slope. We don't know the y-intercept. So how are we going to get this equation? We're going to use the point slope form. So we're going to remind ourselves what that looks like, and then we'll go to work. If I look at this, I remember that, oh, I'm not going to make changes here. I'm going to need a y value and an x value from one single point, and I'm going to need the slope. I don't have the slope as we previously stated, so how am I going to find that? Well, I can either do it conceptually and notice that from 3 to 13, the y value changes by 10, and from 2,000 to 10,000, the x value is changing by 8,000. Now I can reduce that, divide it both by 10. That's going to be 1 over 800. So that is going to be my slope. It doesn't reduce, it doesn't divide out evenly or anything. So that is simply my slope. Okay. Now if you say, Mr. Harrington, use the formula. I use the formula. So let's use the formula. Okay. The y value of our second point is 13 minus the y value of our first point. That's 3. 10,000 minus 2,000. It's going to be 8,000. So we're going to get 10, and we're still going to get 8,000, and we're still going to get 1 over 800. So we still get the same slope, whether we use the formula or did a conceptual approach to what is the change. Okay. Now let's get rid of some of this stuff so that we have enough room to work the rest of our problem. All right, now it's gone. Now we've got some room to work. Let's remind ourselves that our slope was 1 over 800. We need to select one of the points, substitute into the equation the way that we've been doing, and we'll get our answer. So I'm going to use this point first. Y minus y1, y minus 13 is going to be equal to 1 over 800 times x minus 10,000. That's all there is to it. You used the second point. If you happen to use the first point when you were doing your work, your answer should have looked like this. Y minus 3, you still should have gotten 1 over 800 as your slope. And then it's going to be x minus 2,000 for an answer. Okay, so either of those would be the correct answer for this problem. How'd you do? Hope you're doing well on these problems involving taking a verbal description, essentially a word problem, and creating a linear equation based on the information you're given. Now let's work one where we're given a table. Here is our table. Remember that the table is giving you information. It doesn't look like it's been provided in a verbal problem, but it is information nonetheless. Let's see how you do. Welcome back. We're going to take information in this table, and the first thing I'm going to do is remember that this XY table provides me with 3 points, the point 2, 1, the point 4, negative 3, and then the point 5, negative 5. 3 points. I want to write the equation of the line. I have no slope. I have no y-intercept. So that means I've got to be using this point slope form. That also means that I'm going to need to use the slope formula in order to get the slope. So we'll use the formula and we'll do the conceptual thing too. The conceptual one's going to be a little bit tricky, so let's see how you did. Let's just select the first 2 points to work with. If I go from 1 to negative 3, 1 to negative 3, how far is that? How much of a change is that? Think about the number line. From 1 to negative 3. First of all, we're going down, so that's going to be a negative number. And how far down? 0, negative 1, negative 2, negative 3. We're going down 4. So our change in y is down 4. What about the change of x? We're going from 2 to 4. That's going to be up 2. So that's a positive 2. So our problem now reads negative 4 over positive 2. A negative divided by a positive is going to be a negative answer. And 4 divided by 2, not only does it reduce, it actually divides out evenly. And consequently, we simply have a slope of negative 2. That's the conceptual way of doing it. Let's plug things into the formula. We're going to have y of our second point minus y of the first point. That's negative 3 minus 1. X of the second point minus x of the first point. That's going to be 4 minus 2. Negative 3 minus 1, it's negative 4. 4 minus 2 is 2. And we still get that same slope, negative 2. Okay? So there's our slope. Now what? Make use of that friend right there. Let's start plugging stuff in. Y minus y1. Let's use the first point. Y minus 1 is going to be equal to negative 2, because that's the slope, times x minus, which x value? Which one went with the 1? The 2 did, so we're going to put that there. You need to remember to use the x and the y from the same point. If you mix it up, it's all over with. You're done. Okay? If you did not use the first point and you used the second point, your answer would have been this. Y minus negative 3. Wait a minute. How do I write that? Minus negative 3. Let's clean that up just a little bit. Instead of y minus a negative 3, let's just call that y plus 3. And that's going to be equal to negative 2, because the slope's still going to be negative 2. And then we're going to have x minus 4. What if you use the last point? The last point. Now you're going to have y minus negative 5, because that's the y value of the last point. We'll minus a negative. Remember, we're going to be a little more high schooler with this. Instead of minus negative, we're going to go ahead and make the change to plus 5. And that's going to be equal to negative 2 times x minus 5. So if you've got any of those 3 answers, you got this one correct. So congratulations. Let's do one more. This one's going to be a graph. So let's see what this one looks like. Okay, here we are. This is our graph. Same rule as before. I want you to write the name of this line that we have this beautiful picture of, right? Hit the pause button and we'll see you back in a minute. All right, welcome back. As I look at this graph, I'm asking myself, is there any way I can get a slope and a y-intercept? The previous problems, we've not been able to do that. We've had to do some work to calculate those values. But on this picture, I'm actually fortunate because I can get all of the information just by studying the picture of the line. First of all, I'm going to look at this point right here. That's where it crosses the y-axis. That is at the point 0, 2. That's my y-intercept. That's my b value. My b value is equal to 2. Now, what is the slope going to be? It would sure be nice if I could figure that out as well. Now, you might remember from an earlier module, this line, if I look at the right-hand side of it, it's going down. So I know that this slope has to be negative. Whatever the number is, it's going to be negative. So I need to go and find some good, clean points to help me calculate the change in the y value over the change in the x. So here's a nice clean point right there, or I could use this one back here. Either of those will work just fine. Whichever two you pick, select the one on the left first. Okay? So we want to figure out what is the change of the y value. Well, if we look at this is point number 1 right here, and this is point number 2, the y value is way up here for point number 1, and it's right here at point number 2. What did that do? It went down 2. So the change in y is down 2, so we're going to say that's negative 2. Now what about the change in the x? The x value of that first point started way over here and ended up right here with the red point. How far did that change? Well, it went 1, 2, 3. Now 3 to the right, that's obviously going to be positive. So we've got negative 2 going down, 3 going to the right, and so the slope of our line is actually negative 2/3. We expected it to be negative. Okay? If my answer had not been negative, I would have hit timeout. Let's go back and recalculate, because I would have done something wrong. Because as we stated, the right side of the graph is going down. It's decreasing. The slope has to be negative for that to happen. So there's our slope, negative 2/3. Notice that I didn't put my delta x right there. Change in x is what that should have been. So as I look at my answers here, what do I have? I have a y-intercept. I have a slope. Which equation do we use here? Do we need that point slope? No, we don't, because we've got a m and we have a b, so we're going to be using the y-intercept method. So it's a very simple model. Y is equal to mx plus b. So we'll simply fill in the numbers. Y is equal to negative 2/3 times x plus 2. And that will be the answer that we've got there. Okay? Hopefully you did well on that. All right. After working through some or all of these problems, if you believe you are struggling too much, you might be doing some things incorrectly. First of all, confusing the y-intercept with the x-intercept. We haven't even mentioned the word x-intercept, but sometimes students get that confused. We're looking for the y-intercept. We're looking for where does it cross the y-axis, not the x. We don't really care about the x-axis right now. All right? The other thing that can happen is we calculate our slope incorrectly. Now that's a rather technical formula, y2 minus y1, and until you get accustomed to using it, it can be somewhat daunting, and students, frankly, they just tend to make mistakes sometimes. But you need to pick a point to be your first point, a point to be your second point, and then make sure you plug the values in appropriately. Don't mix them up. Don't interchange point 1 and point 2. Just be very careful about plugging the numbers into the formula. The other thing that can happen is you end up with the wrong slope sign. you end up with a negative slope instead of a positive slope. That can happen from making addition and subtraction errors on the formula. All right? Take a look at it conceptually if you are able to do that, or make sure you're careful with your addition and subtraction using the formula. Now, the other piece of that, maybe you're struggling because you're still not sure which form of the equation to use. When do I use slope-intercept form? When do I use point-slope form? Okay. If you're struggling in any of these areas, what you should do is go back and re-watch video number 1 of this module number 6. Watch it with your eyes and your mind. Don't worry about trying to take notes, just watch it. Focus with your eyes and your ears and your mind, all three of those together. Then come back, take another look at this video, work through these practice problems again. And by then, it's possible, in fact, probable, you'll be good to go to work on the quiz. All right? That concludes this second video of module number 6 of the Essentials of Algebra 1. We'll see you next time.